Welcome back. This is Nick Agram. The arcs of a circle and the central angles and the circle sectors. Those are the topics that I will discuss, maybe in this video or on the next video. But the arcs I want to discuss. Okay, let's see. Okay, it's time to go back to the circle once again. I have a circle that is, if I can write here, yes, I can write circle U. As you can see here, I have a circle U. I have the diameter, which is the line NM. And then I have the radii, I have UM, I have UN, the line UN, and the line OU. Those are my radii. And then I have a minor arc, minor arcs. We have OM, and we have ON, big N. Those are my minor arcs. And I have a major arc. We can start with O, N, M. Okay. And then we have the central angle. This is our central angle. And and this is the length of my arc. Okay, so we're going to look for the length of the arc. I will go back to this one. If I'm going to have a circle, let's have a circle. That's good. If this circle, the circumference of that circle, circumference of that circle is the diameter times the pi, or the twice the radius times the pi. But if I'm going to half it, semicircle, and I will just find this length. So semicircle is equal to the whole circumference divided by 2, or the diameter times the pi divided by 2, or 2 times the radius divided by 2, and divided by 2. 2 times the radius times the pi divided by 2. As you can see there, it's only radius times pi. How about if I'm going to half the half, or the 1/4, and I'm going to just this one. Maybe I can find this one. Then I have 1/4 of a circle. Then it should be C divided by 4. And it should be D times pi divided by 4. And it should be 2 times radius times pi divided by 4. And as you can see, then it is the half of the radius times the pi. So, if, as you can see here, the whole circle has a circumference of the diameter times the pi. The semicircle, it is half the circumference of the circle. The 1/4 is just the 1/4 of the circumference of the circle. Here, as you can see, it is 3, maybe another pen. We'll give you another pen. It is 360, like I discussed in my previous video. The half of it, the semicircle, is just 180 degrees. That means that is 360 degrees, or sorry, 180 degrees. That means that it is 180 divided by 360 degrees. That means it is 1/2, like what we got here. 1/2. If I have a 90 degrees, that's 1/4. Then I have 90 of 360. Then you will see it is 1/4. That's why we have 1/4 there. That means if I'm going to find the circumference of any sector, any arc, the length of any arc, we'll get another, the length of any arc, length of arc now, it is given by L, then it is always the angle divided by 360 degrees multiplied by the circumference of the whole circle. So if I have angle divided by 360 degrees, multiplied by, if I'm going to use the diameter, then it's times the diameter times pi. But if I'm going to use the radius, then I have angle divided by 360 degrees multiplied by 2 times radius times pi. Then you can simplify that. So always remember that. Always remember. Okay. I'm going to look for the circle sector now. If I have this circle, and if I'm going to This is the diameter, give a diameter. If that's the diameter, and then this is the center, and then I have another like that. Okay, this is now my circle sector. This is my circle sector. Okay, I'm going to do the same thing with, like what we did with the arcs, like that. If I'm going to take half of this, and then I'm going to find the area of this. So area of a circumference, of a circle, sorry, area of a circle is equal to pi times the square of radius, or pi times the square of the diameter divided by 4. That's the area of the whole. So if I'm going to have the half of the area, just the half, then I need to put half of that also is equal to pi times d squared divided by half of 1/4 is 1/8, as you can see now. So if I have 1/4 of the area, just the 1/4 here, this one, then I have pi times radius squared divided by 4, or pi times d squared, 1/4 of 1/8, that's 32. So as you can see now, if I have any area of a sector now is equal to, if I have any, it's not exact, it's not 90, it's not 180. If I have exact, it is always like angle divided by 360 multiplied by the area of the circle, of the whole circle. So we have angle divided by 360 degrees multiplied by pi times radius squared, or angle divided by 360 degrees multiplied by pi multiplied by the diameter divided by 4. That's how you solve the area of a circle sector. I hope that you learned something from this video, and in my next video I will be discussing some examples of the arcs, the circle arc and the circle sector, and the length of the arc and the area of the circle sector. That is what I'm going to give more examples on my next video. So see you around.